channel. So today we will be solving n queen problem. So what is n queen problem? N queen problem is nothing but you have a chessboard of, for example, here we are taking chessboard of 4 by 4, and you have 4 queens, right? So given n by n chessboard, you have n queens, and then you have to place the n queens in such a way that none of the queens no kills the another queen. For example, if you place one here, right, the first queen here, and suppose you are putting the second queen here, and third queen you are suppose putting it here, right? So when you are putting the third queen at this place, you can see this first queen will be able to kill this third queen, right? So you have to place it in such a way that none of the queens will be able to kill anybody, right? So for example, like okay, let's take an example where we are able to find out the solution to how to place the queen, right? So yeah, so basically let's put one here, first queen here, and the second queen, let's place it here. The third queen we can basically place here, right? And the fourth queen we can keep here, right? So if this is the case, you can see this queen is not able to kill anybody because none of the ones are coming in his way, in her way, sorry. So yeah, so this one either can move in the forward direction or the no, either it can move in the row or in the column, or it can diagonal, right? So if you'll see, like none of the ones are crossing each other, so it will not be able to kill anybody in the solution. So we have to place it like that, right? So okay, so what is the approach we are going to follow to solve this is consider each row every time. So suppose for example we are taking the first cell as a queen. So we have to check if this is one of the feasible solution. If means if this step that we have taken is going to one of the feasible solution, then in the next row we will be able to place one somewhere, right? So we'll try to place the one here. Is it possible? No, it's not possible. So we'll leave it. We can place the one here in the next row, right? Is it possible? No, it's not possible because this one will be able to kill this one diagonally, right? So this is also not possible. So this cannot be part of solution. Can you place one here? Yes, you can place one here because this one will not be able to kill any, like this new one, right? So this will be a part of the solution. Now we'll move to the next row. Next row we'll check, can this be a one solution? No, because this this one will be able to kill this one, so this cannot be part of the solution. Can it be placed here? One? No, because this one basically will be able to kill it diagonally, right? So this cannot be a part of the solution. So we'll place here. Is it safe to place one here? No, right? It's not safe. So basically we'll cannot keep it here. Can we place it here? One? No, it's not possible. So this is not a feasible solution, right? So we have to backtrack basically and make it this 0, and again try with this solution. So we'll place the one here, and then again we'll follow the same procedure until now we reach to the final solution, right? So okay, so basically this is the way we have to approach the problem, right? Okay, so now we'll do the coding, like how to code this problem. So basically I'm using Java to solve this problem. Okay. Yeah, so basically we have created a project, and in that project in source folder we are going to create a class basically create a main method, uh, right? So under the spin, what else we need? Like we need a scanner class, right? Definitely to take the input, which will basically take the input from console. Now what else we need? Yeah, we take an integer where basically keep the value of the user input, like what size uh, it needs. Okay? So basically now we'll need a matrix also to operate on that matrix. Matrix integer, and this will be of size n, right? Yeah, now we basically need to you know uh, initialize this matrix with 0, where we have to find the solution, right? So yeah, this will be n, and matrix of I j will be basically equal to 0, right? So it's always a good practice to keep a space so that code will look good, it will be visible to the others when others are looking into it, right? Okay, so we'll basically try to find out the solution of it. So how we can find out the solution? So we'll create a method public static. We'll keep static on it. Boolean, which will basically tell us if we have find the solution or not, it's true or not. Find solution. What we need here, right? We need a matrix for sure. And what else we need? We need the row number. So basically how we are going to proceed is like one by one we'll proceed with each row. So we'll try to put the value here. If one solution for one value, we'll try to put the next values here. We'll see like if it is feasible or not, if it is taking us to the feasible solution or not, right? So obviously we need the row value, right? So it's row, obviously the size of the matrix, right? Now, so what we'll do for each row, right? For every row, basically, we'll keep it as j instead of I, because this is going to be the column value, right? Because we are going to pass the value like this: the first, second, third, fourth, right? So this is the way we are going to do. So for simplicity, we'll we keep it as j. Okay. Now what we need to do, yeah, we'll keep the value at each place, and we'll see like if it is safe or not, right? So if so we'll basically using a function method basically, which will tell us if it is safe or not to keep the value as 1 at that particular index, right? So what I'm trying to say is like, we'll suppose we're keeping 1 here, and then we'll check if it is fine to keep 1 here or not. So for example, if I'm keeping 1 here, we have to basically find like if it is safe to place 1 here. If it is safe to place 1 here means like if it is coming in any column which already has 1, or a row which already has 1, or a diagonal which already has 1. So if it has already 1 in row, column, or diagonal, we cannot keep it there, right? Because it will be killed by that another queen, right? So basically we have to keep it at such a place that it will not contradict with the is safe condition, right? So for example, we'll write this function later. As of now, we'll keep in mind that this is going to return a true or false based on the safety, if it is safe to keep the 1 at that particular index or not. Now what we'll do, if it is safe, then we'll simply, so we'll keep matrix as this is row and this is j. So if it is safe to place it here, we'll basically uh, uh, mark it as one. That is, then this place can be, one possible solution, and it can be marked as one. And like what I mean to say, queen can be placed there, right? And then we have to move to the next row. So in next row, what we'll do basically, we'll try to find solution. Okay, so find the solution for the next row, right? So in next row, what we'll send matrix, and obviously the next row will be row plus one, and the size of the matrix is n, right? So this is it, right? Okay, so okay, so what we'll do here, we'll basically check, like, if this is returning as the solution, right? If this is returning as a solution, then fine. But if it is not returning as a solution, right, it can be possible that we may lead to the wrong solution. If this is the case, if it is not returning as a solution, then whatever assumption that we have made here, that this is a safe solution, we'll have to track back, right? We'll have to basically assign it back to the zero, because we our assumption failed, right? Our assumption failed, so it has to be assigned with zero, the previous state, basically, right? Yeah. So this is one condition that we fulfilled. This is fine, uh, right? Yeah. And after this all happens, like if even after uh, parsing the whole the whole row, if we are not able to find the solution, then basically we have to return false, because we did not find the solution, right? False. uh, yeah, and one more condition that I think we're good here. Yeah, main thing we forward. So what if, like, we find out the solution, right? If we reach to the last row and we have the particular solution which is working, right? So basically what we'll do, how to identify that situation is like, if row equal to n, means we have reached to the last row and we have found the solution. Then what we have to do, basically we have to print. Oh my god, hate writing for loops. I just hate in squares. So yeah, but in this case we have to write, no other choice. Yeah, so basically, if it is n, we have reached to the final solution. Final row means we have the solution, right? So for that we'll simply print it, matrix I j, right? And once we are here, we can see that we have reached the solution. And if, yeah, and yeah, there can be multiple solutions also, right? So basically we have to return false here, so that it will go for the next solution it will try to find out. Okay, we are good here, good here. Yeah, okay, now we have to write the if statement. So we create a static method. What else we need here? The matrix is mandatory for sure, right? And then we have, what else we need here? Yeah, row and column value, right? So this is a column value, and then row value, like for the particular index we have to check, right, whether it's safe to keep that uh, cell has one or not, right? Okay. So coming back to the matrix, so what we have to check for this one, we have to check if the row has any one, or we have to check if the row has a value or not, any ones or not, column has any ones or not, and left diagonal and right diagonal. So for this case, suppose, so left diagonal if it has any one or not, and right diagonal it has any one or not, right? So this is the condition for the queen to be placed at a particular place, if it is safe to place that queen at that cell or not, right? So basically we have to write here three things. Column check. So first we have to check if it is safe column wise. If it is no, left diagonal, check, and then right diagonal check, right? So these three things we have to write. Okay, so yeah, this is simple. We simply have to keep it as we have to simply check the row, right? Sorry, column. So column, like if matrix of column, right? Column will be fixed, column value will be fixed, and j value will be moving, right? So it's equal to 1, then in this case we have to return false. Means we have found some contradiction here. After this, we have to go for the left diagonal check for I. Okay, how to find the left diagonal then? So left diagonal will be, the value will be decreasing, row value and column value will be decreasing here, right? So this value will, if you'll see, is row -1 and column -1. If we'll go in this direction, it will be like row -1 and the column +1, right? Okay, got it. So basically we have to take I and j here. J is equal to this will be row and this will be column, and I should be for the greater than equal to 0, and j should be greater than equal to 0, and I should be minus minus, and j minus minus, right? So yeah, now matrix simple thing I j is double equal to 1, then what we have to return false. Means we have found some value which is contradicting our pin placement, right? So for the same thing, so what you have to do here, in the right diagonal, basically you have to check I is decreasing and j is what, j is increasing, yeah. So I is equal to row, comma, j is equal to column, and I should be greater than equal to 0, and j should be less than n. N is the size of the matrix, right? And I values should decrease and j value should increase. This is the condition, right? Let me check one more time. So I row j is column, I is decreasing, so it will go up, and j is also, j is increasing, so it will go till n. Yeah, we are good here. Now same thing, if matrix of I j equal to 1, then we return false, right? And if nothing happens, nothing is contradicting that way, then yeah. So if nothing happens and nothing is contradicting, then we have to return true here, right? uh, that's it, I guess. Oh yeah, sorry, yeah, we have to send the matrix as a parameter plus row and plus n, right? uh, yeah, no, column also we have to send. So column will be basically j, right? J will be the column value and the row value will be the row, and then is the size of the matrix. Yeah, we are good here, right? Let me verify one more time. So this safe method is basically checking the column diagonal, left diagonal and right diagonal, and then in safe method, if it has reached to the nth row, we have to simply print the matrix because we have find the solution, and we have to return false because we have to find the next solution also. Now here, for each column in the row, basically we are checking if it is safe to place that one or not, and if it is safe, we are assigning it to the matrix. If it is not safe, then we are returning false, right? Then we are trying for the next value, and if it is safe, then we are going to the next row. We are doing row plus 1, and then if it is returning false, then we are backtracking and we are assigning the value as 0 again, and then we are trying for the next value. Yeah, I think we are good. So okay, this is it. Yeah, okay, sorry. We have to call the main method also, right? From main method. Okay, find solution matrix. First row will be provided as 0 because we are starting from 0. Yeah, and the size, matrix size. That's it, I guess. Okay, so let's run and see what we are getting. Okay, so let it build. Is it building? Yeah. Okay, so we are providing the matrix size as 4. Oh, okay, okay. We have to print it in such a way that it won't create a problem, so that we will know visible. Don't. Okay, so yeah, so after the matrix also will print this out. This one will remove. Okay, we are good now. Check for 4. So yeah, this one is not contradicting anything. This one is also not contradicting. This one is also not contradicting. This one is also not contradicting. Yeah, we're good here. And the next solution is not contradicting here. This one is also not contradicting. This one is also not contradicting. This one is also not contradicting. Yeah. Okay, so this is good, right? We have a right approach, and we found the solution. Let's try for 5 also, 5th matrix. Okay, we have a lot of solution here. We will verify one. So 1 we are good here. 1 we are good here also. For this one we are also good. For this one we are also good. For this one we are also good. Okay. Yeah, correct. So we have the solution. So this is the way, like we basically need to use recursion here in this method, and we have to basically check. The main thing is like check if it is safe to place it there or not. If it is safe, place the one at that particular index. If it is not safe, then try for the next value. If it is safe, then find the next row value where we can keep the our one at that particular index. And then if it is not safe, sorry, okay, if it is like try for the next value, and then if it's returning, if it is leading to no solution, like if this is returning false, then we have to basically track back, and you have to assign it to 0, whatever you have assigned here 1, because you thought like, okay, your assumption was like, okay, this will lead us to correct solution, but it's not leading us to the correct solution. So we have to know reset the value as 0, and we have to try for the next value, right? And is safe method is quite easy actually. So we have to basically check the column if the column has any ones or not, if the diagonal left diagonal has any one or not, right diagonal has any one or not. I hope I have cleared my point. If you like the videos, please share with your friends. If it was informative, if it was knowledgeable, please share with your friends. Ask them to subscribe my channel. You also subscribe my channel. That's it, guys. We are good for the day. Thanks.